Hello everyone, this is the third class covering the Ergun equation in a gas phase reactor. So just to recap, in the previous video we found this equation here, dP over dW, which we use the Ergun equation to rearrange and find dP over dW. This equation here can be simplified more. So if you see these group of variables all the way to here, they're all constant. So we can represent that with the letter alpha. Okay, so therefore we can say dP over dW equals alpha times 1 plus epsilon x times P naught over P times T over T naught. And as we said in the previous classes, that we're working with an isothermal reactor, so therefore this is 1. Okay, so that's our dP dW. Our dx dW is this equation right here, which we solved at the first class using the material balance of the packed bed reactor. We can also get rid of this term here, which is 1. We can rewrite it to dx over dW equals K Ca naught times 1 minus x divided by Fa naught times 1 plus epsilon x. Now for P over the P naught, which is the initial P, we will write that as y. So we'll say that y equals P over P naught, just to represent it with a parameter, represent pressure with a parameter. Okay, so we'll say times y, and that will be our first equation. The second equation, which is dP over dW, will also implement the parameter y here. So dP over dW equals alpha 1 plus epsilon x times 1 over y. Okay, you can change this also in terms of P. So we can say, hey, we'll times this by P naught over P naught, which is 1. Okay, and since P naught is a constant, it can go inside the differential. So it'll be P naught times differential of P over P naught. Okay, which will be P naught times dy. Okay, and therefore we'll have P naught dy over dW equals alpha 1 plus epsilon x times 1 over y. To get rid of this P naught, we can divide it in this side just to get rid of it. Okay, therefore dy over dW equals, we'll call this alpha nu, since P naught is a constant, alpha nu times 1 plus epsilon x times 1 over y. Okay, and that is your second equation. Let me bring this down here. Okay, so using these two equations, you can size the packed bed reactor and solve for a packed bed reactor. You won't see these, you won't be asked to solve these two equations in an exam because you need an Excel or MATLAB to solve them. but you could be asked to drive these two equations. But yeah, that's it for this class. I might do another class solving an example using these two differential equations, solving them on Excel. But in order, as I said in the beginning of the Ergun equation class, that in order to solve the mole balance of a packed bed reactor in a gas phase, you need another equation, which we found to be here, equation 2. And hopefully I'll do another example, another class with an example specifying how we can use both of them simultaneously to solve for a problem. Okay guys, that's the end of this class. Bye bye.